First up, I think we're going to talk about transition library, and if it really, I don't know how you feel about it, Ed, but it seems like transition library is kind of the workhorse
Oh yeah.
of motion, at least in Corona. So I got the documentation. I wanted to bring up the documentation before we start our conversation here.
All right. That's a
Let me
good idea.
just yeah, let me just grab my screen over here.
Especially the easings page. People often don't notice.
Yeah, let's see here. Do you have a? Can you see my screen now?
I can in fact see your screen.
Okay. Yeah, and it's real. I mean, we won't spend a lot of time here because I know you've got some examples and code and stuff to walk through. But I just want to kind of draw people's attention to the documentation because it's pretty straightforward. And some of the items here I thought we could just kind of talk about real quick that are interesting is the fact that you can pause the transition. So if you have a transition that's in play, then you can pause it or resume it. I also thought it was interesting, and I'm not sure if you have this in your examples or not, but I thought it was interesting that you can tag certain transitions, so you can specifically name and address those transitions. And also being able to have, I like that here it talks about having more than one transition at a time, or more than one on an object at one time, and then you can pause or resume that object globally. So if you have like a separate movement or a separate fade transition on an object, then you can kind of affect both of those at the same time. So I thought that was really interesting. And then the other thing that is kind of worth pointing out here is there's 42 easing methods, built into Corona into this transition library. And I thought that's pretty significant. It comes with some out of the box functionality, kind of ready to go. You don't have to figure out all those different types of easings to apply to your tween. So you have anything to talk about there, or anything?
Yeah, scroll back up a little bit so I can talk to your points there. I just one, I agree with you absolutely that it is the workhorse. It is a workhorse among two different ways of moving things. You're basically two ways of moving things. Three programmatically by yourself. That kind of sucks. No good. No fun. I'll say that nicely. Transitions. I use it all the time. In fact, I would say that I've almost never written a single game or app that did not use at least one transition in it. And more often than not, transitions dominate the movement within my games and apps. And then, of course, physics, which I believe, and I would suggest to people that they not combine physics and transitions, although you may, in certain cases, do so. There are appropriate cases. So I agree that it is a workhorse. And I just wanted to say, you asked me, you didn't know if, you said, I don't know if these are in your examples. And pause, resume, cancel tags, all that good stuff. We will talk about that, but not today. I consider those sort of like intermediate level discussion, and I wanted to just do basic talk today. And in the future, we can talk about more of the advanced features or intermediate features.
Okay, that's good. Let me just go back to the statement you made just a moment ago about transitions and physics, not using them together. So give us just a short answer as to why that might be.
Well, okay, so within physics, or when you're using physics, one of the ways, among a few, to move a body is to use the set linear velocity, or you could use apply force or apply impulse. So set linear velocity, what you're saying is give this physics body a specific movement rate. It moves a certain rate in x and a certain rate in y. Then you could apply a force alternately, and what that does is it applies a certain amount of force for one frame, and then you need to continue to apply that every frame, and what it does is accelerates the object. Finally, impulse, which is you do it once. It's sort of like you could think of it as sort of like a strong force, which is only done once. And it's like hitting the object and giving it, like bouncing it in a sense. So those are all great ways to move things with physics, but then transitions themselves, you could say move the object from this x position to this x position, or this y position to this y position, or a combination thereof. So imagine that you have set the linear velocity of an object to be, say, moving upward, so in the negative y direction, But then you do a transition. You could do a transition where it is transitioning from one X position to another, and those two would work fine because they're not conflicting. You're modifying the X with the transition and the Y with the set linear velocity. But as soon as you say transition in the Y, that will dominate. Whatever the physics engine did doesn't matter because the transition, I believe, is going to execute last, and that is going to be what the user sees. So it was pointless to do both together.
So while they both create movement, the overlapping behavior doesn't make sense to use overlapping behaviors.
Not necessarily. I mean, there are always cases. I don't like to say, oh, never do it.
Never say
there are
never.
always cases, and I've found many cases myself where it makes sense to do this. But generally, I would suggest, especially for somebody newer to game development, is learn about transitions, use them for your game if you want to, and then if you're going to play with physics, but don't combine transitions and physics to move your player or your enemies until you get a better understanding. For example, one great example of a way to use both together is if you've ever played Galaga, making those little curving paths. That's a beautiful use of physics combined with transitions. The transitions are great. They would be great for making that curving S path. But at the same time, you've got the physics part of this thing going on. So you've got the collision detection, you've got all the other good stuff happening, and you've done a good combination.
Okay. All right. Well, I just want to make sure I know sometimes we say things on the show. It's kind of like, just want to follow it up with a why.
Yeah. In fact, I would suggest that although we're doing a very basic game in terms of the mechanics for this first one, in the future, it's completely possible that we might examine a game that would combine physics and transitions.
Okay. Okay. All right. Well, I know that you've created some samplers and some code and things like that. So
yeah. So let me go ahead and bring my screen up.
Okay.
And I will discuss what we've got.
Okay. Excellent. And we just so everybody knows, the code for this is going to be available, so you can download it, play with it, and edit it and use it in your projects and stuff. Just as all the code has been made available in the previous discussions. So we did a whole series previously on Composer, and throughout all of those video postings, you can find the links in the show notes that go to the repos, so you can download the code and mess with those as well. So we want to make sure that everybody has a chance to lay their hands on the code that we're talking about.
Lay your hands on the code. Sounds so right. If you go to GitHub and you go to Ramen Gamer,
lay hands on the code.
That's right. Lay hands on the code. You will see that there is a Corona Geek repository, and under there is the Hangouts repository, repository. And then today we're going to be talking about transitions, and these links will be given in the show. But just in case you're hunting, I suggest you do is go take a look at what I've got. You'll see that we have a transitions folder with a number of different subfolders. Each of these is examples that I'll talk about. And there is another folder here called I Can Make That, which will be where I put all of the game work that we do on the show. So for example, the game we're doing today is Zigzag Boom, and we'll talk more about that in a bit. But as time goes by, there should be more and more game clones or game examples here, and more just general content underneath the Hangouts folder.
Cool. Yeah, and I would encourage anybody who is out there poking around at the repo to go ahead and just hit the download button for the whole blooming thing and just bring it all down, because there's lots of great examples and snippets in there. And if you go back and watch any of the previous shows, you'll be able to make great use of those. And if not, I know Ed does a great job of documenting everything and making comments in his code. So it's just good stuff, no matter how you slice it.
Well, I appreciate that. I was going to say maybe I don't do a great job on the comments, but I try. So,
well, you put comments in. That's a good start.
Yeah, it's a start. It's something. I've lost my screen here. Hold on.
Yeah, we can see it. I don't know about you.
Yeah. Okay, there we go. All right. So, before I show you what we're going to talk about today, I just want to show you what's in the folder for people who sort of want to get ahead. If you download the Transitions Examples folder, you're going to see 5 different subfolders, one called Basics, another one called Easings, intermediate, custom, and then what I called Ask Ed. Out of these, 1, 2, 4, and 5 are finished. The intermediate folder is currently pretty much not empty, but not functional. So don't expect that to have useful code in it today. I'm going to do some more work on that before we do the next show. So what we're going to talk about today is the basics, but I forgot to mention is the Ask Ed folder is sort of like a an accumulation of answers to forum questions where the person was asking a question, and when I answered, the answer involved transitions in some way. And so there are basically 4 examples. There's a duplicate, rotate about point, that utilize transitions to solve some kind of an interesting problem. And I would encourage people simply to go look at the examples, run them, and say, oh, well, that's what it's doing. And then you can dig into the code and see how I use transitions to answer the question. And I think almost invariably I put the link to the forum post in these. If I didn't, I apologize. But I'm pretty sure that I do put the link in the main.lua file. So, basics. What are transitions? First, I'm not an expert in the sense that I believe transitions come out of Flash and other technologies out there, and that they have become adopted in game engines after they were long since used in web development and stuff like that. But in a nutshell, if I were asked to describe transitions, I would call them a method for changing an attribute on an object over time. And then the way you would change that attribute can be varied with what are called easings. So for example, an attribute we could change on an object is the x position. We could change x from 0, let's say the object started at x0, and change it to 100 over 1 second. And what would happen is the object would visually seem to move from 0 to x100 in 1 second. And then we could change this using a different, varied easings. One of these easings we could use, the traditional one, the standard one, is linear, so that it moves at a rate of 100 pixels, 0 to 100, over 1 second in small slices, and it moves evenly. Or we could use a different easing, like, let's see, in-out circ. And so what that would do is it would move quickly in the beginning portion, then a little more slowly in the middle portion of the move, and then quickly again at the end. And you pointed out the link, but there's 42 easings that are standard easings that you can use. And there's a variety. Like elastic is a nice one. What happens there is if you use out elastic, is it moves quickly in the beginning portion of the transition, and I'll demonstrate some of these in a minute. And then it gets to the end, it shoots past the value it's supposed to hit, and then it bounces back, and it shoots past it again, sort of like a rubber band, which is where the name comes from, elastic. So basics. Some of the, we didn't show it, and I should have showed it. Let me bring it up here. There are a number of transition functions. There are blink, dissolve. It's a little bit hard to see. Let me zoom in here. Blink, dissolve, fade in, fade out, move by, etc., etc. You know, I don't use most of these. Why do I not use most of these? I know you laugh, and I appreciate the fact that the Corona staff has put these in here. But if we're going to talk about workhorses as far as the transition library goes, transition to, transition from, those are the two that I use 99.99% of the time.
Yeah.
All the other ones, except for blink, can be implemented using those two base transitions.
Yeah, and to be fair, they are named or labeled their convenience methods. So you're right, like you say, the to and the from are the kind of the core, the meat of it, and then the rest of them are just gravy on top. So
the transition to and from pretty much give you all the functionality that you would be able to create out of those convenience functions. So I would say that people watching this who are new to transitions, go and learn about to and from, and then consider whether in the future you wish to use the convenience functions, and I think you will find that it's just easier to stick with the to and from, and that it's quicker for you programmatically and learning-wise.
Well, you know,
So,
I think
but I'm going to demonstrate some of these.
you know, with most things, it's kind of like you'll know that you need it when you know that you need it, right? Like when you've exhausted to and from, and you know that like I want to do something different, I want to do something else, and these things don't do it, right? Then you can go in search of something else, but
Absolutely.
wait until you reach that point.
So let me just give you a visual. So the first folder, One Basics, it's got a very simple project in it. You just run it, and then it loads up here, and you see a bunch of dots with some names next to them and buttons that say Start. And if I click the Start button that is parallel to the dot, it will do this transition. For example, the first one is blink. So I click it, and it starts doing a blink. And if you look at the code, you'll see that I set this blink up to have a period of 1 second. So actually, it's not a period. It's a time of 1 second. That would be a period of half a second. Half a second to blink off, half a second to blink back on. So the time for blink, cut it in half, and that's how long it takes to go between each of the states, on or off. The next one here is dissolve. Now, what dissolve is, it's one of the it's actually a weird transition. It's the only one that works on two objects at the same time. All of these transitions typically work on a single object, but transition dissolve, really what it's doing is it's taking two objects that most people will put them on top of each other, and it's transitioning visibly between one to the other. So I've got it twice, and I'll show it to you. Let me restart this so the blink isn't annoying us. I will click this one, and what you're going to see is this will go from red to green. Really what you got here is you got two dots on top of each other where one is red and one is green. So you get that nice fade over transition between the two. Now here, I've got the red dot here, but I put the green dot here and then hidden it. I've made the alpha 0. So when I click this, you're going to see this one fade out and this one fade in. So that was the same transition that occurred up here, but I simply moved the other object. So you look like you're raising your hand there.
No. So you applied a movement.
Dissolve. Yeah. Let me show you the code so this is a little more clear.
Okay.
So the blink is I used a helper function which I wrote up above. This is in main.lua, by the way. For all of these examples, I have a helper function that creates a circle, and it draws the text here, and it fills in the color, so I don't have to write the code over and over. So I can make all of this in one line of code. So for the blink example, which starts down on line 91, I create a circle, I fill it with white, I give it a red border, which is what you're seeing here, and then I create a button, and that button will call this function, which for whatever reason I called on start. I should have called it push or do it or something. It doesn't matter what I called it. And what it does is it hides the button, and on line 100 it does the work of the transition. It says transition blink circ, which is the circle that was returned by my helper, time 1000. So blink over a time of 1000, a period of half a second. Oh, and this is the time is in milliseconds. So, and then let's go to dissolve. So with dissolve, like I said, this is one of those the weird transition that uses two objects or applies to two objects. What I did here was I made two circles, one right on top of the other. So x140, y130, and then these two fill in. So just to demonstrate what's really going on here, let's make this one not quite far enough over. So there, now I've moved the first circle over and not moved the second circle. So you can see there's two circles going on at the same time. Undo that. And when we run this one, transition dissolve, we pass in circle 1, circle 2, and a time. Just directly in, no table, nothing. And what that does simply transitions the alpha for each of those. So one goes from 0 to 1, the other one goes from 1 to 0, but not exactly. It's not exactly that. I don't believe it's a linear cross. I don't think that they both hit 0.5 at the same time. I think one is leading a little bit. That's my sense. It's a little bit hard to tell, but maybe somebody from the forums will know, or somebody from the staff will know. It's not a really critical question.
But to the eye, it serves the purpose.
Yeah, to me, well, okay, so when I separate the two circles in this example, let's go ahead and I set this one to alpha 0. So now both circles are 100%, they're alphaed out, or 100% alpha. Now I click start. That didn't seem to me like they faded at the same rate. That one seems like this one came up a lot faster, and it could be simply because it's green. It could be a visual artifact of the color, right? Tricking the eye. So, but if I do it again, see how fast that one came up? Whereas this one took a long time to fade out.
Yeah.
So, all right. So, very interesting, but not that interesting.
Well, good to keep in mind.
Yeah. So I don't think before today. I think may have used dissolve one time only. So now on to my favorites, to and from. So a lot of people get into there. They use these for the first time. They're like, well, what's the difference? What's the difference between to and from? Here's the difference. To is transitioning from where the object's value is. Let's use X as an example. So the X position is right where the dot is now. And the transition is going to go from wherever it is now to wherever you tell it to go, to the X position. That kind of makes sense. From is saying whatever I put in from the X value, as soon as it starts transitioning, it's going to, boom, zoom over there, and then it's going to come back to where it currently is at. So let's take a look at the code before I press it. What I've done here for the to is I've said transition to the circle, this here, to whatever my current position is, plus 80 pixels. So what I'm telling it to do is move 80 pixels to the right. And it's going to do that in 1 second. It's also going to move from the current Y position over to plus 80 pixels. And I'll explain in a minute what this table is and how it works, but just bear with me. So when I click this, what's going to happen is this circle is going to move down and to the right. Now, let's go look at the from example. If you examine these side by side, let me just copy the code and paste it. These two examples have exactly the same encoding here. X circle.x plus 80, circle.y plus 80. But the from is going to do exactly the opposite. Let me uncomment this. It's going to, this is, as soon as I click start, this object's going to move down here, and then it's going to come back up to the top. And that's all there is to it. There's no mystery. It's important for people to understand that when the transition to and froms execute, what happens is, internally, the transition library says, okay, I'm looking at this object, I'm going to take a sort of like a snapshot of these different values that you're changing. What are they currently? And it's going to keep track of their current value. And then it's going to start to change that value over time. So with the to, no big deal. It's straightforward. Take the current value, add something to it, or subtract, whatever you may be doing. Change it to something else. But the from is saying, okay, this is where I want it to be to start, and then I'm going to move back to my current position. So,
okay, yeah, that makes
the reason this is important is because people do silly things sometimes with transitions. Not on purpose, maybe, but just because they don't understand. One of the silly things that they may do is they may add a transition to an object, and then a moment later do another transition on the same object. For example, this might happen, let's say that you have an object in your game and it's moving along and the user touches it. And then by touching it, they run some code that adds a transition. But then the user clicks on the object again just a moment later as it's moving. So then you put another transition on there. Same transition code. So what's going to happen? I ran the same transition twice. What's going to happen is the first transition is going to be executing. Let's say it's going to be moving this object from left to right. And then I apply another transition just a few milliseconds later or half a second later. What it's going to do is say, oh, okay, well, the object is now starting here, but it's going to the right. Let me just demonstrate. So here's this, like, see how it's got that little jog at the end?
Yeah.
What happened there, if we look at the code, is I've applied the same transition at 2 different times. So what I did here is I did a transition from x to x plus 80 over a time of 1,000, and then I waited to start that for 800 milliseconds. But then I did another transition right afterwards that started immediately. There was no delay. And again, I'll get back to these parameters in a minute. So what's going to happen here is it's going to start moving. This one's going to start executing first because there's no delay. And then 800 milliseconds, it's going to say, oh, okay, I need to start moving this. But the critical thing is when these 2 lines of code execute, the transition code takes a snapshot. So they both think at the moment this code executes that X is here. But when this one really starts doing the work, it thinks that the thing should be way over here. So what you can get is these weird artifacts occasionally where it's like popping back and forth, and you're like, well, why is it doing that? And the reason it's doing that is because one transition got executed instead of the other transition. Whoever goes last, in a sense, is going to win the battle. Gotcha.
Okay, that makes sense.
Because the code, another thing people don't realize with Corona is that it's not threaded. It's just one thing after the other is executing. It's a big list of steps that have to occur frame to frame, and then it just starts all over again on the next frame. So I'm not saying that you can't have 2 transitions at the same time, but what you want to be careful about is modifying any particular parameter. So these are both modifying the x, which is going to give us this conflict. We're going to get this weird visual. Maybe that's what I wanted, was a weird visual artifact. But, probably not. Rather, I could remember how we did the transition where it moved from left to right and down? I could have done that with 2 transitions. I could have broken it up, if I wanted to, into 2 different transitions. And I did. And the reason I want to do that is, you remember how we talked about the easings? Mm-hmm. So this one here, when I do it, it moves down in a straight line. But what if I wanted it to move in a curve? What if I wanted it to move down and then sort of like curve around? How could I do that? I could do that by having 2 overlapping transitions that use the same time but different easings. So the first one is going to move quickly from left to right until it gets about 50%, and then it's going to slow down as it goes the rest of the way from left to right. Whereas this one is going to, I'm sorry, the first one, yeah, I always get these back, in and out. I can't remember. The point is one moves quickly, the other one moves slowly at the first half, and then it sort of flips the other way. So if it moved quickly in the first half, the second half of the move is slower. It gives it what do they call the circular motion. Let me just show you what happens. I'm going to do each one separately so you can see by themselves. Okay, yeah, so it starts out in circ, starts slowly, so it started slowly, and then it speeds up as it moves to the right. Now, I'm going to comment that out. I'm going to run the Y movement without circ. Now it's going to move quickly and slow down as it moves to the bottom. So it's going to quickly move down and then slow down. So that doesn't seem very interesting. You're like, yeah, whatever. But now let's put those 2 together. Run the linear, this one, transition 2 first, so you can see the difference. It's going to move in a straight line. Move diagonally. What this one's going to do, it's going to move in a curve.
Okay,
you see how it did that little jog at the end there?
Yeah. Oh, that's pretty cool.
Yeah, exactly. This is how you get interesting circular motion out of transitions. And there are 40 other easings that you can apply to get a variety of interesting transitions.
So what I hear though there is that just make sure that you understand when the timing of when things are going to happen.
Absolutely. And this is one of the things that I do all day long, and we're not going to have time to go over it, but this is one of the things that takes so long when working with clients is you're like, oh, we're using this easing to move something. You're like, I kind of like it, but could you make it move a little quicker at the end or a little faster at the beginning? And you're like, oh, man. Unless you're real familiar with the math of how these easings work, it's really hard to do that off the cuff. So I made a project, which I'll show you next week, called Easings, where you can click on the values in the tool itself, and I'll just open it so while I'm talking here, but we'll go over it in more details. And you can change the values, and then you can see what the different easings will do with different timings. And the two tests are shrinking and growing and moving left and right. So let me get back to the arguments, and then we've got to go to the discussion of our game development. Otherwise, we're going to run out of time.
Okay.
So with transition to and from, they both take one argument at the beginning, which is the object you want to modify, and then they take a table of parameterized field names and what the value is supposed to be. For example, I want to modify my circle object, and I want to change, let me zoom way in so you can see this. And I want to change the x, so that's the parameterized value that I want to change. And I want to change it to this. So that's what this part of the code is saying. Change x to whatever it currently is plus 80, and then I pass in a time, and I say time equals 1,000. That means do this over a period of 1,000 milliseconds. And if I wanted to delay it after the code executes, but before it starts to do the work, I could say delay equals and say 500. I would say wait 500 milliseconds and then start doing the transition. And then if I wanted anything besides a linear transition, I could say transition equals easing, and I could use dot one of those 42 transitions. So, and you can find that information on the easings page, which is you go to transitions, click on easing, and then it gives you the name of all of the different easings, and it gives you a nice little visual sort of description so you can conceptually see what the math is doing over time. In other words, it's moving in a straight line over time. Or continuous loop, in sign, out sign. Where's the circ? We just used it. Of course, I can't find it when I'm looking for it. Or elastic. So the elastic's got a very interesting shape. It comes in and it changes up and down. It basically, this is your target value, right? So it's this is where you're starting. This is your target. It's shooting past the starting value, and then it hits the target. And that would be in elastic. But out elastic is it zooms quickly to the target value, shoots past it, comes back, shoots under it, shoots past it, and then it sort of wobbles out until it's on the value. That's what this little graph is telling you. In-out elastic is the combination of those two. It wobbles around the starting value, shoots quickly to the target value, wobbles around, and then steadies out. And then out-in is basically it's the counter. It wobbles around the middle and then hits the top.
So right there, I mean, you can see the value of having these already kind of pre-written for you so that you can just tap into them and you don't have to worry about doing the math.
Yep. And just as a hint, or not a hint, but like a teaser, we're going to look at how to do a custom easing. If 42 easings is not enough, you can write your own. That's how awesome Corona is. You can write your own. So we will go over that at a future date.